So now what we're going to do is talk about energy a little bit, or mechanical energy. So we've talked about two kinds of energy. We did kinetic and potential. So now we have this sort of baby step. Let's do a baby step here and talk about mechanical energy. E, mechanical. Is it a new kind of energy? No, it's just K plus UG. Okay? It's just saying it's the total energy. In our little world, where all we have is kinetic energy and gravitational potential, then the total is just the sum of the two. Okay, that's all I'm saying. Okay. Blah, 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 blah. Kinetic plus gravitational potential. So now we're going to talk about the conservation of, and we'll say mechanical energy. Okay, so energy is conserved. That's the big news. Okay, it's conserved as a scalar, not a vector. So that's what's a little bit different. The conservation of mechanical energy stated thusly: E mech, mechanical, equals a constant. For an isolated system. That's it. That's all we got to say. And you may say, where does work fit into this? Work can transfer E, energy, between kinetic and UG, and gravitational potential. Okay? So if something is inside the system, it can push it and make it change. If the Earth is part of the system, that's a little bit weird and vague sometimes. But that's the idea, is it's constant as long as there's no external forces changing it. Okay? Now, what I like to do at this point is talk about all the different ways you can use that equation, okay? That it's equal to a constant. You'll see it written a bunch of different ways. And I want to show you that they're all the same, and we're going to show you how to use them. So as we do different problems for the rest of the lecture, we'll use different versions of this thing, okay? So, more useful versions than this. How are you going to use this, right? You don't even know what the constant is. So let's look at some more useful versions of conservation of energy. Let's see. One would say, well, if it's a constant, then what is the change equal to? The delta E mechanical equals 0 if it's constant. Right? So this is why energy problems are good for like before and after. We started here and we ended up here. Well, the mechanical energy here is the same as the mechanical energy here. Or if you really are into differences and you know what the difference is, you could say E mechanical final minus E mechanical initial equals 0. That's another way you can use it. Now we're actually getting useful. Because you can have a problem where you have a final state and an initial state, and you can calculate those two, and their difference should be 0. In the hand push example, isn't the potential energy raised while the kinetic energy is a constant? That's because the hand was an external force. The system was just the chalk and the earth, and the hand did external work. So that was not conserved there. We'll show you problems where it is conserved. Let's see, so that's a useful version. But then we can get even more useful, is we can say, what is the final kinetic mechanical energy? E mech final is the final kinetic plus the final gravitational potential, right? So you could say those are the finals, and then minus, what's the initial? Kinetic initial plus gravitational potential initial. And those have to be equal to 0. Okay? So that's something you could write. And then you could also you could group the kinetics. You could say, well, in that case, it must be that the final kinetic energy minus the initial kinetic energy plus the final gravitational potential energy minus the initial gravitational potential energy has to be equal to 0. Okay? So then you get down to sort of the useful version. Okay? So really the useful versions are coming. I should not have boxed these. Okay? So here they come. Then you just group those two. And you say, okay, that means that the change in the kinetic energy plus the change in the gravitational energy has to equal 0. And I boxed that one, so it must be important. Like that. This is what we'll use when there's like a process. Okay, so I'm going to show you problems, and we'll solve some of them with this. Process. Something happens. What was the change when it happened? What was the change when it happened? Add them up, set them equal to 0. Or you could you could go back up here and take that to the other side. Right? You could basically say the other one was that the initial kinetic plus the initial gravitational potential, right? Kinetic initial plus gravitational potential initial equals the final kinetic plus the final gravitational potential. All right, those are equal. And this is good when you have an initial final. Okay, they're all exactly the same. I'm just finding different ways to write it that is more tied to a problem. So if you have a problem and all you know is that Emac equals const, you don't know what to do with it. Right? So this is the point. You think about changes, and then often you plug and chug into these.